Tonka trucks are a testament to human creativity, the ultimate symbols of childhood chaos and legends of durability. These classic toys are built for endless adventures, whether they're hauling dirt in a sandbox, surviving backyard battles, or rolling their way through generations. But behind their tough reputation lies a fascinating world of engineering, design, and precision craftsmanship. So, what do you think? Are Tonka trucks just overhyped relics of the past? Or are they actually over-engineered masterpieces? How did a company that started with garden tools transform into a toy empire that bulldozed its way into the hearts of children around the world? Before diving into the process, let's rewind a bit. Lynn, an aspiring inventor in Minnesota, had a vision for toys that weren't just playthings. They were miniature marvels of durability and realism. He wanted to make toys that could survive being dragged through the mud or even run over by a bike. No shortcuts, no compromises, just tough, realistic metal trucks and construction equipment. It all began in 1946 when three visionaries, Lynn Everett Baker, Avery F. Crounce, and Alvin F. Tesh, founded Mound Metalcraft in an old schoolhouse, which produced gardening tools rather than toys. Then, in 1947, they switched gears to metal toys, and wow, that changed everything. Baker worked in the basement of an old schoolhouse using steel tougher than what's found in modern cars. He started off with two toys, a crane and a steam shovel, and they weren't just good, they were built to last. By 1955, they rebranded as Tonka Toys Incorporated. Those early trucks were built to last, made from 20-gauge automotive steel with solid rubber tires. Yes, they were heavy, but they were almost indestructible. Rubber tires were replaced with plastic over time, but that iconic steel design, it's still the heart of every Tonka truck. Today, that modest start has now grown into a huge 3/4-mile-long plant in Minnesota. From a schoolhouse basement to an industrial powerhouse, Tonka has come a long way. The journey begins with meticulous planning, where each Tonka toy is carefully designed and every part is drawn out in detail. The design process likely uses advanced computer-aided design software, just like most companies in the toy industry. CAD allows designers to create accurate 3D models of the trucks, making digital prototyping easier. This helps designers identify and fix any issues before moving to physical manufacturing, a smart way to save time and money. Once the digital prototypes are perfected, the design moves to the tool room. Here, solid blocks of metal are expertly cut into the dies and molds needed to bring those designs to life. These molds are essential because they will be used to stamp out hundreds of parts, including plastic ones, all created right on site. But let's talk about the foundation of every Tonka truck: steel. Tonka trucks are usually built using heavy-duty, 20-gauge automotive-grade steel. This steel is thicker and more durable than the steel found in most automobiles, and it gives the necessary strength to withstand rough play. The factory uses an astounding 20,000 tons of it annually. Some models even include heavy-gauge aluminum, making them just as tough, but a little lighter, perfect for little hands to handle while still being nearly unbreakable. In just a split second, heavy-duty hydraulic presses cut and shape the parts with precision, much like a massive cookie cutter. Although die casting isn't used for all metal parts, it is used for those complex designs. High pressure is used to force molten metal into molds to create those smooth, detailed features. Even the leftover scraps are put to good use. They're recycled to ensure the process remains efficient and sustainable. Once the parts are ready, they make their way to the sub-assembly line. Plastic components of the truck, like the seats, steering wheel, dash, and the big Tonka truck wheels, are made by injecting liquid plastic into steel or aluminum molds. But how do you manage to stamp out about 2 million parts every single week? And how does a perfectly built toy get made out of so many parts? A huge team of workers jumps into action, each member contributing to the completion of this gigantic puzzle. It's like watching teamwork at its best. Next comes the painting process. A toy like our powerful dump truck undergoes a thorough chemical wash to remove impurities and guarantee a perfectly clean surface before getting its striking, vibrant colors. Then comes the first coat of paint. The toy is completely submerged, guaranteeing every nook and cranny is covered. However, the second coat is where the true craftsmanship takes place. A skilled operator takes charge, expertly applying a second coat of paint with a sprayer, and the last coat is applied with an electrostatic technique. After being charged with electricity, the paint spins off a disc and wraps itself around the toy. Finally, the painted parts are baked at 325 degrees until they're completely dry. Once that's done, they're ready to move on to the main assembly line, where they'll join the remaining parts to finish the toy. And of course, you can't forget the wheels. Every truck needs a solid set to get rolling. When every part of the mighty dump truck finally comes together, it's the hands of dedicated workers that make the powerful dump truck come to life. No matter how small, each detail is carefully added, often by hand, displaying an incredibly high degree of craftsmanship. At the peak of production, more than 1,500 workers coordinated to assemble almost 400,000 toys in more than 100 different designs every single week. It's a buzzing hive of activity, filled with precision and passion. Once the trucks are completely built, they roll down the line just like their life-sized counterparts. And the final stage is packaging. Tonka trucks are available in a variety of packaging styles. You'll often see window boxes with transparent displays, allowing children to see the toy before purchase. Blister packs are a popular choice for packaging smaller toys effectively. For larger models, sturdy boxes or cardboard packaging are used to keep everything safe during shipping. Vibrant colors and the iconic Tonka logo on the box guarantee immediate brand recognition and excitement. Those freshly packed boxes are loaded onto trucks, ready to hit the road. And so they set forth, bringing happiness to countless lucky boys and girls across the globe. These durable tiny machines take off on the factory floor, halt briefly at warehouses, and then roll out to every corner of the globe. But here's a fun fact you might not know. The name Tonka comes from the Sioux Indian word meaning great. And honestly, could there be a better fit? Because this place actually lives up to its name in every way. Its people, its goods, and its mission. It all started with Mr. Lynn Baker's vision to build toys that weren't just fun, but built to last. And let me tell you, he nailed it. Hasbro purchased the company in 1991. Today, Tonka isn't just a brand, it's a badge of honor. Tonka takes pride in its hardworking team, its innovative plant, and the timeless toys it brings to life. Did you know that the Tonka truck was inducted into the National Toy Hall of Fame in 2001? It should come as no surprise that it's one of the most iconic and cherished toys ever produced. And if you're a die-hard Tonka fan eager to see all 3,000 toys Tonka has created over the years, you're in luck. The Winifred Museum in Winifred, Montana displays the entire collection. Tonka has expanded into dolls, sculptures, stuffed animals, and even video games during the last 4 decades. But let's be real, Tonka trucks are still the star of the show. With over 30 different models and millions sold every year, these trucks have been a favorite for generations. Thanks to the vision of 3 Hennepin County residents, who in 1947 revolutionized the toy industry with their durable, lifelike, and useful designs. So, what's your favorite Tonka truck memory? Was it building sandcastles with a dump truck? Or maybe racing a bulldozer through the backyard? Let us know in the comments below. We'd love to hear your stories. If you enjoyed this behind-the-scenes look at how Tonka trucks are made, don't forget to hit that subscribe button and ring the notification bell so you never miss out on more fun stories like this.
RC cars. They're fast, aggressive, and engineered to dominate any terrain. Whether it's ripping through dirt trails, drifting around corners, or launching off ramps, these miniature machines are designed for maximum performance and durability. But behind their high-speed thrills lies an incredible world of engineering, design, and precision manufacturing. For decades, RC cars have evolved from basic wired toys to high-speed off-road beasts and race-ready machines built for serious enthusiasts. Brands have continuously pushed the limits, creating lightweight yet durable chassis, high-torque brushless motors, and advanced suspension systems that allow these cars to reach speeds of 100+ miles per hour. The technology behind them has never been more advanced, blending precision engineering with cutting-edge materials to deliver unmatched speed, power, and control. Today, we're taking a deep dive from design and prototyping to assembly and final testing to see exactly how RC cars are built for action. Remote-controlled vehicles weren't invented for fun, they were built for warfare. The earliest radio-controlled machines appeared in the early 20th century, with military applications taking priority. During World War II, Germany experimented with radio-controlled tanks and explosive boats designed to strike targets remotely. These machines were built for destruction, not entertainment. But as technology advanced, manufacturers saw a different kind of potential in remote-controlled vehicles. By the 1960s, the first commercially available RC car hit the market. An Italian company, Elettronica Giocattoli, developed a 1:12 scale Ferrari 250 LM. Compared to today's standards, it was primitive, but it sparked something big: the idea that RC cars could be more than just a novelty. The 1970s and 80s saw an explosion in RC car popularity, particularly in the United States and Japan. Companies like Tamiya, Kyosho, and Associated Electrics pushed the boundaries, introducing faster motors, rechargeable batteries, and custom kits that transformed the hobby into a competitive sport. Tracks, clubs, and RC racing leagues emerged, turning what started as a niche hobby into a thriving industry. Fast forward to today, and RC cars are more advanced than ever. From brushless motors capable of 100+ mph speeds to aerospace-grade materials and precision suspension, modern RC cars can rip through dirt, drift like a pro, and launch off jumps. What started as a military experiment has evolved into a global obsession, with cutting-edge engineering making today's RC cars faster, tougher, and more capable than ever. Step 1. Designing from concept to reality. Every RC car starts with digital engineering, where designers use CAD software to create detailed blueprints of every component. In high-end racing models, engineers even run airflow simulations and weight distribution tests to ensure stability at high speeds before anything is physically built. Once the digital design is finalized, the next step is prototyping. Many manufacturers use 3D printing to create early test models, which are put through rigorous testing for balance, handling, and durability. If an issue arises, where the car lacks grip, feels too heavy in corners, or struggles on rough terrain, it goes back for adjustments. Only after flawless performance is achieved does the design move on to mass production. Over the years, some brands have mastered the craft, turning RC cars from simple toys into high-performance machines. Tamiya, known for its legendary build-it-yourself kits, introduced many hobbyists to RC cars in the 80s and 90s. Their models focus on scale accuracy, detailed bodywork, and full customization, making them a favorite for both racers and collectors. Traxxas. When it comes to pure speed and durability, Traxxas dominates. Their ready-to-run models are designed for blistering acceleration, with some breaking 100 mph straight out of the box. Built to handle everything from street racing to off-road bashing, their cars set the standard for performance. Arrma RC cars are some of the toughest in the industry, built for extreme off-road action. Their reinforced chassis, heavy-duty suspension, and rugged builds allow them to survive massive jumps, crashes, and brutal terrain. Team Associated, a dominant name in RC racing, prioritizes low weight, sharp handling, and high-speed cornering, making their cars a top choice for competitive drivers. Losi creates high-performance models, balancing on-road precision and off-road power with brushless motors, advanced shock absorbers, and realistic body designs. Their engineering makes them stand out in both racing and bashing categories. These brands have shaped the RC industry, proving that great design isn't just about looks, it's about performance, durability, and innovation. But even the best design means nothing without the right components to bring it to life. Step 2. Building the chassis. With the design finalized, the chassis is the first major component to be manufactured. Acting as the car's structural backbone, it holds everything together, from the motor and battery to the wheels and suspension. Most entry-level RC cars use plastic chassis, which are lightweight, cost-effective, and flexible enough to absorb impacts. However, High-performance models opt for aluminum or carbon fiber chassis, offering greater strength, rigidity, and improved handling, essential for high-speed racing and off-road durability. The manufacturing process depends on the material used. Plastic chassis are created using injection molding, where molten plastic is injected into a metal mold, rapidly cooled, and formed into the final shape. Metal and carbon fiber chassis are crafted through CNC machining, where a computer-controlled milling machine carves out the precise structure from a solid aluminum block or carbon fiber sheet. Once the chassis is built, it's time to add real power, the motor and electronics that bring the RC car to life. Step 3. Installing the motor and electronics. The motor is the heart of an RC car, dictating its speed, acceleration, and overall performance. There are two main types. Brushed motors. The older, simpler design, while easy to maintain and budget-friendly, they wear out faster due to friction from internal brushes. Brushless motors, the gold standard for performance. These motors are faster, more efficient, and longer-lasting, making them the only choice for serious racers and high-speed enthusiasts. To power the motor, RC cars require a serious battery setup and not just your average AA's from the store. The two main options are nickel metal hydride batteries, which are affordable but heavy with less power output, and lithium polymer batteries, which are much lighter and pack more power, allowing RC cars to hit higher speeds with extended run times. To regulate power, a small but critical component is installed, the Electronic Speed Controller, ESC. Acting as the car's throttle system, the ESC controls acceleration and power delivery to the motor. A high-quality ESC results in smoother handling, better responsiveness, and faster speeds. With the power system locked in, the RC car is nearly race-ready. But raw speed means nothing if you can't turn on a dime and hug the track. That's where the steering system comes into play. Step 4. Steering and suspension. If you've ever driven a cheap RC car, you know the struggle. Some feel like they're skating on ice, others are too stiff, and some just don't respond fast enough. That's where steering and suspension systems make all the difference. The steering system is powered by a servo motor, a small but powerful device that moves the wheels left and right. High-performance RC cars use high-torque metal gear servos, which are faster, more durable, and highly responsive. These servo housings are typically injection-molded plastic, while the internal gears are made from CNC machined metal to ensure long-lasting durability and precision control. Then comes the suspension, one of the most critical components of an RC car. A stiff suspension makes the car bounce uncontrollably, while a soft suspension can make it feel sluggish and unstable. To strike the perfect balance, top-tier RC cars use oil-filled shocks, similar to real sports cars. The shock bodies are CNC machined aluminum, giving them strength and heat resistance, while small rubber seals inside prevent leaks. Each shock is filled with silicone-based oil, which absorbs impact and smooths out handling on pavement, dirt tracks, and rocky terrain. Step 5. Body design and painting, the finishing touches. Now that the RC car has power and control, it's time to give it a signature look. The body of an RC car is typically made from lightweight, impact-resistant polycarbonate plastic, designed to withstand crashes while keeping weight to a minimum. Manufacturers begin by creating precision-engineered molds, then use vacuum forming or heat shaping to mold the plastic into the desired car shape. Once the body is formed, it moves to the painting and detailing stage. Some RC cars come pre-painted with factory graphics, while others are left for customization. Enthusiasts often use airbrushing, custom decals, and hydro-dipping techniques to create one-of-a-kind designs, from replicating real race cars to crafting unique, high-art paint jobs. Once the paint is cured and sealed, the body shell is attached to the chassis, completing the transformation from a collection of parts into a fully functional RC speed machine. Step 6. Testing and quality control, built to perform. Before an RC car is ready for store shelves or the track, It goes through rigorous testing to ensure speed, durability, and handling meet factory standards. Engineers run a series of performance tests, checking acceleration, steering response, and suspension behavior under real-world conditions. High-end manufacturers even conduct stress tests, launching cars off ramps, pushing them to high-speed impacts, and running them through off-road simulations. Only after passing every performance and durability test do RC cars make their way to hobby shops, online stores, and racetracks around the world. And that's how RC cars are made. From precision design to high-performance engineering, each step is crucial in creating the ultimate racing experience. Thanks for watching. Make sure to subscribe and hit the bell for more behind-the-scenes looks at how the world's coolest products are made.